Chapter 9, Lesson 5, Tangents and Secants. So we're continuing our work with circles here. From Chapter 9, earlier lessons, we talked about chords. And so we know that chords are a line segment going through the circle, but not necessarily landing on the center line. So the definition I have here is if two chords intersect, the angle formed is 1/2 the sum of the arcs. So I have two chords here, and I have this angle here, and it's created from where the two arcs intersect. And so I would take the measure of DC plus the measure of AB, and then half. The next one says if two tangents share an endpoint, the measure of the angle formed is 1/2 the difference of the arcs. So we're talking about angle D right here, and they're saying it's half of the difference. So I take AEB minus AB, and half of it would equal angle D. If I have a tangent and a secant, so a tangent, remember, is a one that touches in one spot, which we've talked about. Secant is new, so a secant is a ray through a circle and continues outside. So I have this secant here going through the circle, and it's telling me that the angle formed, which is angle Y, is half the difference again. The last one said if you have two secants, the angle formed is again half the difference of the arcs. Okay, this first one we have two chords, and so in order to figure out angle 1 for this one, I do half of my chords added together, and so that would leave me with angle 1 to be 65 degrees. On number 2, I have a tangent and a secant, so that one is half the subtraction of the angles. So that would give me angle 1 to be 50 degrees. Number 3, I have two secants. So again, it's half of the angles subtracted, which would be 25 degrees. And number 4, I have two tangents, which one more time is 1/2 the difference, which would give me 100 degrees. Use the diagram at the right to complete exercises 5 through 7. If MN is 100 and PQ is 40, and those are two chords, so to find measure of angle 1, I'm going to do half of the addition of those chords, which is 70 degrees. Next one says if MN is 60 and angle 1 is 50, find PQ. So I'm going to set up my formula with half of the arcs added together is going to equal 50. First thing I'm going to do is divide by half. So it's going to give me 60 plus x equals 100. Subtract 60, and I get x to be 40. Next, if PQ equals 90 and measure of angle 1 equals 60, find MN. So then I'm going to set it up as half of the arcs added will be 60. Divide by half, which gives me 120. Subtract 90, which gives me 30. And this one I have two tangents, and it says that YWZ is 280. So then YZ must be what's left of 360 minus 280, which is 80 degrees. Measure of angle X would be half of their differences, which is 100. And next one, if YZ is 75 and WYZ must be 360 minus 75, 285, And then angle X would be half of their differences. So half of 285 minus 75 is 105. Next, if measure of angle X equals 80 and YZ equals 100, then YZ equal WYZ equals. Now there's two ways we could go about solving this. We can set up our formula, which said that half of their differences, so if I do X minus 100, should equal 80. Divide it by half, which gives me 160. Add 100, which gives me 260. Also, I could have just said, I know that YZ and YWZ equals 360. So if I know that YZ is 100, I know the other one has to be 260. But I've proven it both ways. And last one, again, I can prove it both ways, but it says that angle X equals 55 and YWZ is 200. I know that YZ would have to be 100. But again, I could set it up as half of 200 minus X equals 55 times, or divide 55 by 0.5, which is 110. Subtract 200 from both sides. 110 minus 200. And then divide by, they must have typed something in wrong because we got X to be 90, YZ, angle YZ, or arc YZ. But according to this, that is not what we should have gotten. This should have been 160 anyway. It's bad 6.